Hello and welcome to another tutorial. So this time we are going to be kicking off a new series, setting up a bunch of elements for a RTS, a real-time strategy game. So to begin with, I'm going to focus actually on the camera aspect of it. So what we're going to be looking at is how we can set up a camera. So we're going to be setting up things there in terms of being able to zoom in and out, being able to pan around the level, and looking at a couple of key useful things there just to set up a really nice camera for then going forward. So let's dive on in. So to begin with, I've already set up a very basic terrain using just some very basic textures for this. And now what we're going to do is we're going to focus on setting up the camera side of this. So what I'm going to do, how I'm actually going to make this camera work, is I'm going to create an object that is going to be our camera focus. So we're going to have a camera focus object, and this will be completely separate from the actual camera itself. So we have our camera focus, and what I'm going to do is just for really our testing purposes, add a little marker sphere there. We'll get rid of the collider. So our camera, we can see where it is there in terms of that's the camera focus. So I'm just going to move that down to be on the terrain. And what I'm going to do is this essentially is going to slide across the terrain and the camera is going to look at that. So let's set up our script here. So going to have our scripts folder, and under this, so we're going to have quite a few different things. We're going to have our camera one, and this is going to be our RTS camera. So the idea will be is that this marker, this camera focus, will move around the world, and the actual camera is going to be able to focus on that. I am very intentionally not having the camera parented to it. So the reason for that is I want to make it very easy for being able to blend the camera's location so that we can smoothly transition. So the idea can be is the camera focus can move really quickly. The actual camera itself will blend its location. That's going to give us smoother camera movement. So, okay, we have our RTS camera script. Going to attach it to this. So first thing I want to do is really just get the camera looking at that object. That's really the first bit of what I want to focus on. So, okay. What I'm going to do is it's going to need a link to the particular focus target there. So I'm going to have serialize field, game object, camera focus. And what I also then want to do is, because it's going to be working with the camera a lot, I'm going to actually have a linked camera. That what I'll do is I'll retrieve that in awake. So linked camera, get component, camera like that, just so we've got that ready to go. So, okay, we can link up those particular ones. But in terms of controlling where the camera is, I want to control two aspects of it to begin with. One is how high above the marker we are. The other is how far back from the marker we are. So what I am going to do is, because I feel like this is something where we're going to be configuring quite a few different things, I'm actually going to set up a class here that I'm going to mark as serializable. And this is going to be our camera config. And I'm going to have a public float. And this is going to be the height offset. And then I'll also have a horizontal offset. So I might set these both initially to 20. have here serialize field camera config, initial config. So this will just describe where that camera is located. So let's link up all of the different bits for the camera. Let's make sure that we've got those elements coming through. So that's good. So now let's get it actually looking at it. So what I'll do is in start, I want to, because this is something I'm going to be doing quite a bit, I'm going to have an update camera position. And then I'll set up here, void update camera position. So now I need to calculate where the camera's location is. To do that, first I need to know where the focus location is. So we're going to have vector 3, camera location. Well, firstly, we get the position of the camera focus. Now I need to offset that. So firstly, I'm going to do the height offset. So we can add to that our initial config, our height offset multiplied by vector 3 up. And then we need to bring the camera back. So I'm going to have a camera location, and let's assume that horizontal offset is relative to the forward. So what I'm going to do is, because if it's relative to the forward, I actually want to move backwards. So I would say the horizontal offset, not vector 3 up, but actually our camera focus, transform forward like that. So we've brought the camera up, we've brought the camera back. Now we need to make the camera look at that actual focus. So what we can do is, first I'll reposition the camera. So linked camera, transform position is that new location. Now we make it look at it, which I can go linked camera, transform, and I can tell it to look at. And we've got a few different options here in terms of how we handle that looking at. I'm going to use the one where we provided a target and the world's up location. So we can say, I want it to look at the camera focus, transform, and I want to use world up. That should be enough that when I run it, the camera gets relocated and this target is center of view. So let's test this. So we're running it, and we can see it's focused directly on that. So that's good. We've got it looking at the particular object. Now so we have zoom levels happening. So what I want to be able to do is I want to have essentially a zoom level that goes from 0 to 1. So I'm going to have a float initial zoom level, and we might start it at 0.5. And I'm going to indicate that this has to be between 0 and 1. Now our configurations here, we're going to have a configuration for minimum zoom config and one for a maximum zoom config. We're going to set up also a tracking here of our current zoom level. And that can be like that. For now, I will also mark this as public, just so we can easily test out the zooming in and out. But what I can do is current zoom level is the initial one here. In update, I'm just going to, well, I wouldn't want to normally do this, I'm just going to always be running the update camera position. So, okay, how do I want to blend between these zooms is a really important thing. Because I've got different factors here now where, okay, I've got the height offset. I need to have what is my current working height offset. So I need something where I get a working height offset, and I also need a working horizontal offset. I need to decide how I actually get those. The rest of the code here doesn't change, but what I do with those is quite important. So, okay, how do I want to determine these? So one option is I could just do a straight lerp. So this could be a mathf lerp from our minimum zoom config, height offset, to our maximum zoom config, height offset, based upon our current zoom level. So that, perfectly valid way of setting this up. So I can follow that same approach for the horizontal offset as well. So I'll just use that same setup for now. So, okay, that looks good. I'm going to adjust the defaults here for the actual configs. I'm going to have a new camera config. And what I'll say is the height offset, when we're zoomed in quite heavily, might go to 5, maybe 10 actually. So we'll say it can go to 10, and we'll say the horizontal offset is more like 5. So that's good. That gives us a bit of a different configuration here for that. We can line that up so it looks a little bit cleaner and neater. And then I'm going to do the same for the maximum zoom. Now, actually, how we want to define these is really important, of whether minimum means that we're zoomed very far out and maximum means we're zoomed very far in. So we want to make sure we're consistent from the beginning. I'm actually going to change this around. So minimum, we're actually zoomed quite far out. And we might go to 50 for that. So we've configured those, and I'm just going to also, for the current zoom level, just to make it a little bit neater for testing, we've brought that in. So that's good. And then we can come back here, and we just want to check our zoom configs. So those have not actually configured correctly. So what we can do is we can actually, I'm just going to reset this so it's got the correct values and relink up the focus. Now, let's test this out. So we can see we're offset. So as I zoom out, it pulls back. And as I zoom in, you can see it works quite nicely. That's a very not great zoom though, so I'm actually going to, generally what I find works better is the horizontal offset. That's a little bit better, maybe 75. So we're zoomed quite far out there. And then as we zoom in, that looks a little bit better. I'm going to drop the height offset even further for when we're zoomed right in. So that's good. I'm happy with that. We could also try bringing that to 25, bringing that to 50, maybe even 35. I generally would say the horizontal offset, you may not want to have that be too large, but 3550 feels not too bad. So that looks good. That gives us some new defaults we can put in here. But in terms of that movement, it's, I think we can do better. What I would actually do as a further thing is I would actually set up an animation curve. So I'd have an animation curve, and this would be our zoom mapping curve. And then I would go here and have our effective or working zoom level. Is we do an evaluate of that. This just allows us to change, so if we don't want the zoom to be linear. And it's fairly cheap to do, and it gives us the option then of being able to vary that later, which I think is really handy. So what I can do now is I'll just set that up as a standard S-curve. Now we can pull back out, zoom in, and I think that looks quite good. We could, again, vary with these offsets depending upon what we're wanting that to be. But I think that's quite good in terms of where that's at. So, okay, that's good so far. Let's have this now so that that control of the zoom level is actually happening from user input. And in particular, we want to drive that via things like the scroll wheel, for example. So what I'm going to do is I'm actually using the new input system with this. So I'm going to add a component, player input, and we don't have any of the things set up yet, so I can go and do a create, and I'll put this input config, and we'll call this our input bindings. Okay, so I'm going to set up the binding here for the camera zoom. So I'm going to call this camera zoom, and I'm going to change the action type to a value, and the control type is an axis. Now for the bindings, I want to bring this, I want to grab the scroll. So we can see we can grab scroll Y for the mouse. We could set that up to link to other schemes as well. I'm just going to save that. Then what I can do, because I'm using the send message mode, so I would have on camera zoom. Now with that, what I get is a input value. And to read that, I can go and say, okay, well, the zoom value, or zoom input, equals value, and we go get value, or we can go get, say we want a float, like that. Now the actual inputs we get here, there is a little bit of messiness with that at times. So what I am going to do is I'm actually just going to check whether that is positive or negative. So I'm just going to go, f zoom input is greater than 0. I might make it a very small value. I could go if it's greater than float epsilon. Then what I want to do is say that it's going to need to change the zoom. So update zoom, and I'm just going to put that as a 1. I'm not going to use the actual value that I've gotten there. Otherwise, if the zoom input is less than minus float epsilon, then update zoom minus 1. Then I'll set up my little function here, update zoom delta. And then what that should do is we should have our current zoom level. I want to do a clamp between 0 and 1 so it doesn't change it too much. Current zoom level plus delta. And let's also scale this by a sensitivity. So zoom sensitivity, just so we've got a level of control there with that. Because we don't want it to be changing necessarily a huge amount at a very rapid rate. So I might say the zoom sensitivity, and I'm going to actually set that to be pretty low. I'm going to set it to maybe 0.1. And we might also actually here scale it with delta time, just so we're not able to be changing things too rapidly. And then with that, I can update the camera position. So I would remove that from being here in update. And now I should be able to zoom in and out without needing to change it in the inspector. I should be able to just use the mouse wheel. So let's test this out. So as I scroll, so we can see, okay, that's definitely a little bit low. So we can go and adjust the sensitivity. Going to increase it by a factor of 10. That feels better. Again, I think that needs to be higher. So we'll increase it a bit further. That feels a little too quick maybe. So we might actually drop that to 2.5. The other thing I'm going to do is add in, always good when we've got stuff like this to add support for being able to invert direction. By default, we'll set that to false, but just so that we can actually easily support this, I have working delta. So what I would do is change the delta for inverting the zoom direction, then it's minus delta, otherwise it's the delta value. Always good to add in support early on. For being able to invert the direction of things like that. Just a handy thing to make the game a little bit more usable for folks. So now I should have a zoom that works quite nicely. So I can zoom in and out. That speed feels good. If I invert the direction, then that works. So that's excellent. We've got our zoom working. Now we can actually start to do some panning around of this. We do already have move input being able to come through from the actual input setup. So our input bindings, we do already have move data there. So what I can be doing is let's retrieve that and see what that looks like. So we can have on-camera move, input value, and let's retrieve that. So it would be value get, and it should be a vector 2. So this should be a vector 2 of our move input. And let's just debug log that out so we can see what that actually looks like. Okay, so let's see what that looks like. So as I do use the keys like WASD, we should see input coming through. We're not getting ones coming there, and that's because we need to make sure the name matches. So we can see the names down here on the right, so we just needed to make sure those names matched correctly. So we can see now we do get inputs coming through, so that's good. So what I want to have happen is those inputs, I want them to move the focus. So, okay, let's look at where we want to be doing that. So what I'm going to do is up here, move input, and I'm going to just directly store that here. So I won't actually do the movement at this point. I'm just going to be storing the movement. Then in update, well, I want to actually handle camera movement. So if move input, and I'm going to say the square magnitude is greater than float epsilon, then I need to update the camera position because the camera has actually moved. Now I might split this so that we have move or update the camera focus, location, and based upon that input, and then we update the camera position. So I just want to split those. The main reason being is that I think that it's good to have those, they're serving two different purposes. So good to kind of split them up into different functions so that it's a little bit cleaner and neater. So this will be our update camera focus location. And this is our position delta. Like that. Now our move input, we probably want to have a speed control for that. So we're going to have our camera pan speed. I'm going to set that to probably 50. I think a fairly decent value there for it. So that move input, I'm going to multiply that by camera pan speed by delta time. So we've got the actual amount of movement that we should be applying. So okay, I can update the position now. So what I would be doing is, okay, well, our new position. Firstly, I'll grab the camera focus, its current location. Then that new position, I'm going to add to that camera focus transform, and I'm going to use its forward by position delta.y. Going to do a similar thing and then add in the right by position delta.x. The reason I'm doing it this way is if I rotate the camera, then it means that it's always going to offset in a consistent way. So I'm just preparing for the fact that in future, we're almost certainly going to want to be able to rotate the camera. It's just a little bit of forward planning there. And then all I'm going to do is the camera focus transform position is now going to be set to that new position. Now that should give us a very basic panning around of the world. So let's test that out. So it can run, and we can see it does move around. It does go and move through the terrain and things like that, which is not necessarily what we want. We also actually would very easily be able to get off of the terrain. So what I want to do is I want to be able to constrain this to the terrain, and I actually want to have the camera move with the height of the terrain. So I am going to add in here a terrain, linked terrain. And then we'll connect that up here. So the idea is going to be that I want to be able to have it slide along the terrain effectively, that it constrains it to that. So what we want to do is be able to access the height of this based upon the terrain. Well, first I need to work out where my location is relative to the actual center sort of the terrain. So what I can do is my new position minus the linked terrain transform position. So what I'm calculating here is the normalized terrain position. So at the moment, what I've got is an offset there. Now I need to actually normalize that location. So I can say normalize terrain position, and the X, that I need to scale that based upon the size of the terrain. So what I would do is I would then divide that by the linked terrain and its size, .x. Going to do the same thing for its z value. Now that normalized terrain position, I need to make sure that that's between 0 and 1. So what I'm going to do is actually change this around a little bit, and we'll do a mathf clamp 0, 1. We'll bring this over here, like that. So now I know the x value is going to be between 0 and 1, and I follow the exact same approach for the z value. And then what I can do is I can get the height. So I can go get height. So I'm going to use the get interpolated height because that actually takes in those normalized 0 to 1 values. So we can then just go normalize terrain position.x and normalize terrain position.z. So that gives us our height. And I'm going to store that in the y value. So that looks good. Just zoom out a little bit so we can see a bit more of this. So, okay, what I'm doing here is get the normalized location clamped to the terrain bounds. So now our camera focus won't actually be able to move outside of the terrain. I need to translate that though back into an actual new position location. So what I will do is new position dot x. Well, that's linked terrain transform position x plus our normalized terrain position x multiplied by the size of it. So multiplied by linked terrain size.x. That we'll have similar for the z value. And the y value actually is the easiest one. The y value is just going to, we bring across y. That should give us a marker that slides along the terrain and is constrained to the terrain. So let's test that out. There's a decent chance that a whole bunch of things might break, but let's find out. We'll know if the camera is positioned really weirdly, but we can see it's moving very smoothly along the particular terrain. Now let's see what happens if we try and go off the terrain, and we can't. So this means we've constrained our camera focus to within the terrain. We could constrain it a bit further if we want as well. So we could set up a safety margin. So I'm going to create here light camera and safety margin. And we might say that that is 0.05. And what we then do down here is with these values, rather than it being a clamping between 0 and 1, we could actually then do further applying of the safety boundary. Apply safety boundary. So normalized terrain position x is a mathf clamp from the safety boundary to what so we actually provide the value as well. So we clamp this to between the safety margin and 1 minus the safety margin. We do that for X, and we also do that for Z. Now, we won't be able to go to the very, very, very edge of the map. We'll actually be constrained, so it has to stay within a bit more of an area. We can see if we head way over here, we will hit a point where we cannot go any further. So it can be handy for ensuring that everything stays nicely within view. So that's good. We've got a camera that can pan around, that we can zoom in and out, and that we can safely move it between locations. That's really handy. What if we wanted to do just essentially pulling the focus of the camera from one location to another? So we want to have it transition from one area of the map to another. That could be a really handy thing to be able to do. So what I am going to do is I'm going to way over here. I'm going to create an object, cube. I'm going to bring that down to roughly where the terrain is. And I'm going to set up here a pull camera focus. And the idea is going to be that when this gets run, the camera zooms over to that. Again, I'm going to remove the collider. So what I want this to be able to do is talk to the RTS camera and tell it, okay, I want the camera to focus over on this location. So I'm going to set up a function here, public void, and focus camera on, and it will be given a location. So that's going to be the interface. This, just going to set this up as a very simple thing. Perform action. We'll default that to off. We're going to give it a link to the RTS camera script, because this is really just a way of testing that it's happening. So what I'll do is linked camera, and then an update, F perform action. First thing I do is turn that off. And then I go linked camera, and then I want to be able to tell it to focus the camera on us. So what this needs to do is this needs to now slide that camera location. So the key thing with this is I want it to smoothly transition to that new location. So what I'm going to do is I'm going to reorganize this a little bit. So I'm going to set up so that we can calculate a new location based upon these processes for normalizing it. So just going to add in a little bit more in the way of commenting here. Convert back to world location. And I'm going to set up so we have a vector3 desired camera focus location. That's going to initially be set to our camera focus's location. And then the job of this is actually going to be to calculate where that new location is. So this is going to go, okay, well, that's set to new position. And then here, I'm going to be doing a loop. So we'll set the desired camera location with this. And I can bring that down here as well. So the desired camera location, we're going to assume it's a valid spot, but I could do a processing here where I actually clamp that location. So what I could do is take all of this, get, and we'll say that this is new position. Actually, we can just go direct to the desired camera focus location, is get clamped focus location, and we give it new position like that. Just so we're putting it in a little helper function, because it's something where we're going to be using this a lot. So we get clamped focus location. And all that does is it just performs that process of clamping things to the particular terrain, getting the height. So just a really handy thing to put that into its own little helper function. Because then we do the same thing down here. So even if we haven't perfectly aligned the location, it's going to be able to make sure that it snaps to the right spot. So that's good. Now, this actually changes. What we would be doing is, okay, so what I want to do is check if the locations are different enough. So I can go a vector 3. Now we just have the distance one there. We don't have a square distance. So what I would do is take our desired focus location. I would take the camera focus and its current transform position. And if the square magnitude of that is larger than epsilon, so okay, I need this to move towards the location. If I just do a vector 3 move towards and just directly set the camera location to that, it's going to be able to clip through terrain, which isn't great. So I need to do the move towards, run that getting clamped location, and then use that as the particular camera spot. That's the advantage of having moved that get clamped location logic into its own function. So new position, we do a vector 3 move towards. We're taking our camera focus, transform position. We are moving, not move input, autocomplete has gone a little bit incorrect with that. We are moving towards our desired focus location, and the movement is going to be our camera pan speed by time.delta time. That gives us the new location. And then I would say our camera focus, transform position. We do a get clamped focus location of that new position. So we've split up the process of, we work out where we need to move, and then we manage the actual movement of that. This should give us much smoother movement if we decide to do those large pans there. So let's first test this out that we haven't broken normal movement. So we can see that still works nicely. So that's good. And then for performing our panning, I'll just link this up so it's got our camera script. And what I should find is when I click perform action, we should move all the way over to our target. And then once I'm there, okay, cool, we're at the target, and I can go back to moving around. But if I go and click that again, it'll smoothly move me over to that location. So we've got our basic RTS camera that can zoom in and out, that we can pan around, that we can pull the camera's focus location to a particular area. So we've got a really good setup there now for being able to add and build further things into our RTS system, which, as the series continues, we're going to be doing. So dive on in and experiment with this. See make the terrain look a little bit better, adjust things there in terms of how you might want to have the camera moving, get sort of speeds that feel right. Experiment with stuff there in terms of having the camera focus pull. You could be applying a bit of a curve to that, so it's easing in and out of that process. you could be adjusting the speed based upon the distance that it needs to move. Those are some cool things that you could be trying to add into this. There are a bunch of things that like that we will be adding in future. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, it really helps out, it's really appreciated. If you're looking for the code for the project, the code is available up on GitHub, and the code, you can freely use that in any of your own projects. If you've got any questions, chuck in a comment below. If you're trying to track down other videos, then I do also have a searchable video archive, and there is a link to that in the description below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description as well. But until next time,